Schrodinger wave equation for hydrogen atom. So the first equation in the quantum mechanics was developed independently by Schrodinger. And this Schrodinger wave equation was given for hydrogen atom because hydrogen atom was the simplest atom. Simplest atom. So for hydrogen atom, the Schrodinger wave equation is given by del square psi by del x square plus del square psi by del y square plus del square psi by del z square plus 8 pi square m by h square into e minus v into psi is equal to 0. So this is the Schrodinger wave equation for hydrogen atom. Now what is this psi here? Psi is nothing but the wave function. Wave function. Wave function, or it is also known as amplitude of the wave. Amplitude of the wave. What's the value of the psi signifies? So to describe the position of particle, to describe the position of particle with respect to time. Particle with respect to time. Why with respect to time? We know that the microscopic objects will be under continuous motion. Their position keeps on changing. Therefore, to find out the position of the particle with respect to time, we can make use of this psi. Okay, that's the wave function. And this del square stands for the second derivative with respect to x, y and z. That means you need to do double differentiation. Again, you have 8 is a constant, pi is a constant, that is 3.14. M is nothing but mass of the particle which we are considering. And H is as it is Planck's constant. E stands for the total energy of the system. Total energy. That is, it's a sum of potential energy and kinetic energy minus V. V stands for potential energy into psi equal to 0. So this is the Schrodinger wave equation for hydrogen atom. Now, what is the use of the Schrodinger wave equation? Students, when you solve this Schrodinger wave equation, you will be getting the values for psi. And you'll be getting three values because there are three variables here, x, y and z. When you solve this equation, we get three answers. So using that three answer or three values, it is useful for us to differentiate the types of electron in an atom, to differentiate each and every electron in an atom, and also to locate the position of the electron in an atom. So these three variables are very, very important. For example, in hydrogen atom, there is one electron. Now, how do I differentiate it? In which shell it is there? Or in which subshell it is there? Or which orbital it is there? If at all, if it is an orbital, then what is the orientation of that particular orbital? So, those things you will get to know only by solving the Schrodinger wave equation. The other way to represent the Schrodinger wave equation is E psi is equal to H psi. E psi is equal to H psi. Instead of writing this entire equation, we can also write it as E psi is equal to H psi. What is this H stands for? H stands for Hamiltonian operator. Hamiltonian operator. That means it's a mathematical function. What is this mathematical function? This del square by del x square plus del square by del y square plus del square by del z square plus this constant. The entire thing is taken as Hamiltonian. So that's the Schrodinger wave equation for hydrogen atom.